What's a fact? Like most people think of a fact as like truth, something that happened, something that occurred, like some sort of evidence, something like that. Like fact data is the biggest data that you'll ever work with in data engineering. When I worked at Netflix, there was some fact data I worked on that was 2 petabytes a day of data. So why is fact data so big compared to dimensional data? Fact data is every event that a user can use. So, a company like Facebook has 2 billion users. Every user can do 1,000 or 2,000 events every day by all the things that they're doing. So you do 2 billion times 1,000, you get to trillions of records every day that are generated. So when you're modeling your fact data, you got to be very careful because the volume can cause your cloud bills to go up a lot. So in this 5-hour course that I have put my heart and soul into, we are going to be covering all of the details and the nitty-gritty about how to manage both small volume and large volume fact data. So in day 1, we are going to be covering fact data modeling fundamentals, like what is a fact, like how to model a fact, like how to make it so you have facts that join with dimensions. It's a lot of like Kimball data modeling in the lecture. And then in the lab, we will be covering how to build a fact data model on top of the NBA game details table in the Postgres database. Like if you don't have Postgres set up, follow the link in the description below for the setup instructions. In day 2, we will be covering the blurry line between fact and dimension. So when you aggregate a fact, it can kind of behave like a dimension, and it kind of gets blurry of like what's a fact and what's a dimension. And we're going to be going over that in detail, like how to kind of draw the line between these things. And we'll also be covering the date list data structure, which is a very powerful data structure that is used at Facebook to model user activity. So you can look at like the last 30 days of a user's activity as one integer. So it compresses the data a lot, and it allows Facebook to compute monthly active users very, very, very efficiently. And there's a link in the description below for more details about the dateless data structure. And then in the lab, we will be building the dateless data structure and using fancy bit operations that are in Postgres. It's going to be really, really exciting. And then day 3 will be a deep dive on Shuffle and how you can use Shuffle in Spark and Trino and how you kind of want to minimize it. And the way that you minimize it is through this thing called a reduced fact. So a reduced fact is a way to minimize the volume of all of your fact data by preserving the most important bits. And by building reduced facts, you can supercharge your analytical patterns. So at Facebook, I built a reduced fact framework called the long-term analysis framework. And what it did was it enabled decade-long analyses that used to take weeks for data pipelines to run to now be done in hours. So the way that that works is by minimizing, completely eliminating shuffle, so that allows your pipelines to run as fast as possible. And then in the lab, we will be covering how to build a reduced fact framework so that you can minimize and supercharge the analytics at your company. So I'm really excited for you to check out all this content. I love building this content. And if you want to learn more about how to build this stuff in the cloud with high success frameworks like Trino and Iceberg, I highly recommend checking out the dataexpert.io Academy in the description below. We have all sorts of this content.
Oh, nice, Uma. What was it that made you eventually decide to sign up for the boot camp? It's really interesting, or it's really jarring, I guess, because it's very different to what I'm currently working on at the moment at work. And so I was in a deep technical problem today at work, and then I'm switching to this, and it's a lot of context switching. Yeah, it's a bit draining, but we have we have to do what we've got to do.
That is completely done in the cloud. So I hope you enjoy the course. I spent a lot of time on this, and get cracking. There will be timestamps for every single section in case you want to skip to one or go to whatever pieces you want, since this is a long course. So what's a fact? Like most people think of a fact as like truth, something that happened, something that occurred, like some sort of evidence, something like that. Like a big thing, like you can think of like an action, maybe like a user logs into an app, you Venmo someone $30, you run a mile on your Fitbit. Even though technically running a mile is a little bit more dicey in terms of like what is a fact, because of the fact that a mile is more of an aggregation, because of the fact that you have all of the steps. You can think of each individual step in that mile as like the lowest granularity, because you can't really break down a step into any smaller component. So that's one of the things to always think about when you're thinking about, okay, what is a fact? Like, it should be something that really can't be, it's like atomic. Like, you can't break it down into a smaller piece. And running a mile with your Fitbit, you technically can, right? You can break it down into the individual steps or individual pieces of that all the way down. And so that is something to think about. Facts can appear in all sorts of layers and granularities like that, where you can aggregate up, you can aggregate down, all sorts of, or you can push it back down and like be at the atomic level, or aggregate up to like something like a mile. So one of the things that's really, really, really nice about facts, though, is
Yeah, so just like that's an interesting one because obviously like steps for me versus someone else is going to be very different in length. So I'm not sure that would be a good measurement. Maybe like, you know, I guess market value, would it be more like, um chunks of like 0.1 kilometers and stuff like that. Hi, Munsif. Hi, Yasmin. How are you both doing? And yeah, that's one of the reasons why I joined as well because he seems like a good teacher. So um, that's I like teachers who are quite co- clear and concise. So he seems that way.
is uh, they don't change. They like it's like I took this step at this time, and it's not like I can go back and change that. That's one of the beautiful things, like I know that's one of the things I talk about in therapy sometimes is you can't change the past, and facts are just the past. Like, you can't change the fact that you logged into Facebook 30 times today, and maybe you need to have better boundaries with your phone or something like that. But what I'm trying to say here is you don't have to worry about that part that was a part of dimensions. Dimensions have this like slowly changing transitive sort of property to them that like
Yep, I've got like a notepad here. I like to write my notes on my notepad. I think for me it just sticks better. Um, so I write things down.
kind of make them hard to deal with. But you don't have to worry about that with facts, which is a beautiful thing, very beautiful thing. But facts have their own set of challenges and their own set of problems that, like, honestly, like when I compare facts and dimensions, and if I had to pick which one is easier, like I would say dimensions are slightly easier, and mostly because of what we're about to talk about. Let's go to the next slide. Okay, so facts are more challenging because there's a lot more of them. If you think about it, like, let's go back to the number of steps that you take every day. So if you have 10,000 steps a day, that's a lot more data than you as a person, right? So it's like, instead of having one row of data for you as a person, you have 10,000 rows of data for every step you took. So there's a lot more data. So, and it will scale like way more, right? And like that's an extreme example where like I would say the more of the general rule is there's going to be between 10 and 100x the data that you would see compared to your dimensions. And the big way that you can kind of figure out how big the fact data is going to balloon is based on how many actions are taken per dimension. Like, for example, when I worked at Facebook, we sent about 25 to 30 notifications a day. And so what that meant was from the 2 billion users, that balloons to 50 billion notifications. And that's just a lot of notifications. And I know that a lot of people like turned off their notifications and all sorts of stuff like that because it is like just an excessive amount of notifications. And we're going to be talking quite a bit about these notifications and how they worked and like kind of some of the challenges that I ran into with this very bulky fact data. Another big thing that can be important with fact data that is less important with dimensional data is you need context for effective analysis. For example, say we sent a notification. Well, like, that fact in isolation is pretty terrible. It doesn't really provide any insight. But say we sent a notification and then 20 minutes later you clicked on it and then 5 minutes later you bought something. And we have that funnel of like sent to clicked to bought. And we have that like funnel analysis. And then we have all three of those facts in a line. And then that goes like the first one being like, oh, we sent a notification in isolation. That is worthless. But if you have those three facts together, then you can have a $50 billion business, because that's literally all Google and Facebook are conversion funnels, where it's like, hey, you saw a result, you clicked on that result and you took an action. And they have optimized that really, really strongly. I mean, I don't know if y'all have seen where Google ran this experiment where they tried out 40 different shades of blue for the links on their website. And then one shade of blue caused people to convert and purchase a little bit more than the other ones. And that made them like I think like 10 or like something like 10 or 100 million, some weird number of millions of dollars for just like freaking changing the colors of blue. And so like one of the things to think about like when you're working with fact data is what other data do we need or dimensions do we need to make this fact data more valuable? Like, for example, another way to think about it is, say we don't have that conversion step, that purchase step, but we have the sent and clicked. So we have like the click-through rate. But what if we had another dimension? We brought in the user dimension, and we can see like, oh, users in Canada have a better click-through rate than users in the US, and it's like, why? And that can kind of like kind of slowly build up kind of intuitions and have you ask more deeper questions for your fact data. So that can be a big.
One thing when you think about like this though is just how much is needed to like, or how much you don't realize is going on behind the scenes at like companies like this to get like the performance and the ability to like just do the things that you do on the applications. Though like I do think like when we're talking about like how they've optimized this funnel rate, it's gone a little bit mad in some of them. So like on Instagram, it's ridiculous. I am getting married at the moment, and well, I'm not getting married right this second, but I'm like engaged and I'm planning a wedding, and I saw 5 adverts in a row on Instagram. 5 when I was going through my like friends' stories, like ridiculous. Sorry, that was just a rant. And yeah,
Big thing. Another really common and annoying thing about fact data is that duplicates are going to be way more common, way more common. And duplicates can be caused by a couple different like angles of things. Like maybe the software engineering team, they push out a bug in the logger, so every time someone clicks, it actually logs 2 records, and that's more of a data quality error. But you can also have duplicates that are genuine. Like, for example, in notifications, you can have it where you send a notification, you click on it, like in hour 1, and then you click on it again in hour 7, and those are both genuine actions that we want to log, but we don't want to count that as 2, because then like we could have it where it's like, oh, our click-through rate is 200%, which like doesn't even make sense. Like you need to be able to dedupe a lot of these records when you're working with fact data, because if you don't dedupe, like your metrics are going to look really weird and they're not going to be like what you expect them to be. And that is actually probably one of the most challenging parts of working with fact data, is this kind of deduplication step that can really cause a lot of pain and frustration. So yeah, let's go to the next slide. How does fact data modeling work? Well, you can think about it in 2 ways. On one side, you have there's normalized facts versus denormalized facts, and they both are very important. And I've seen both of them actually be very powerful, and I've seen both of them cause a lot of problems in both cases. Like in the lab today, we're going to be showing how denormalized facts are causing issues. But in a slide here in a second, we're going to be talking about how normalized facts can actually cause issues. So what is the difference between normalized and denormalized? Well, so imagine instead of when you have your record of like Zach logged in at this time, but it wouldn't be Zach, it would be like user ID 17 logged in at this date. And so you would have that as a record. But maybe for your analyses, you want to not do a join. So instead you would say Zach, 29-year-old male, who lives in California, made this logged in at this time. So then you can bring in some of the other dimensions from like the other actors or objects in the fact data. And that can make it so you can just do group by and you don't have to do a join. And that can make things faster. But it can also obviously make things duplicated, because then it's like, okay, what if I have like 50 facts a day? Then we just copy that 29-year-old male in California 50 times. That doesn't sound very, very efficient. But sometimes that is the better option. And we're going to go a little bit deeper into like when that is a better option and when you want to go more the normalized route. The key thing to remember here is normalization. Like, the smaller the scale, the better normalization is going to be as your option. Because when you have normalized facts, you remove all the duplicates and you increase the data integrity, and you don't have to worry about restating stuff. So that's where normalization, especially at the smaller scale, normalization is going to be a big win. And so there is a trade-off between these two, and they both work pretty well. And so yeah, let's go a little bit deeper into this. So one of the things that I think people get wrong here is raw logs and fact data are not the same. Logging and fact data are like inextricably linked. They're almost married, where like if you don't have logging right, it's very hard to get fact data right. So how are they different? I would say a big difference is raw logs are usually owned by people who don't necessarily have really strong data skills. I know at Facebook, when I worked there, the raw logs are owned by software engineers who mostly are responsible for working with online systems and keeping the server running, and they don't really care quite as much about the actual log data. So that's where you can have a lot of impact as a data engineer, is you can work with the software engineers to get the data logged in the correct format, because that will make your life in the fact data modeling layer a lot nicer. So that's one of the biggest problems, right, with fact data is you usually have ugly schemas that are from the online system, and you have other, it could contain duplicates and other quality errors. The raw logs don't have any quality guarantees. The fact data is going to have longer retention, nice column names, quality guarantees. It's going to be just a lot better. Like, the trust in the fact data should be an order of magnitude higher than the trust in the raw logs. And that is one of the biggest things that you can do as a data engineer, is being able to convert those raw logs into highly trusted fact data. You can think of like facts from this angle of, think of this as there's a few here. You have who, where, how, what. That should be who, where, when, what, and how. Sorry, that there's a double how in there. I need to fix that. Okay, so who fields are usually pushed as IDs. You can think of this as user IDs. This could be surface IDs. This could be like, imagine like Tesla has a car and they're driving down the road. There's the ID for you as the user. There's the ID for the car, like the car ID. And you have you have maybe an identifier for the operating system, all sorts of things that like help you identify who is part of the event. And then you have where. Where in this case can be a couple different things. This could be a location, like a country or a city or a state. But this could also be where in the app. Like, are you on the home page? Are you on the profile page? Are you on like where in the app? So this can be very similar, where it can be modeled with IDs as well. But a lot of times it's not modeled with IDs. It's modeled as just like the pages are like /where, or it's like the country or things like that. How and where a lot of the times in fact data modeling are very similar because we're in this virtual world. And so it's like he used an iPhone to make this click. So is the iPhone the where or the how? Because it was on the iPhone, but I would say the iPhone in this case would be the how, and the where is going to be the where on the web page or in the app, or what button they clicked. That is more the where, and the how is going to be more like the methodology. And you could think of this is one where it gets close between who and how are also interesting. Like in the Tesla example, you could think of like the Tesla car as more modeled as a how as opposed to a who. But it's tricky because it is like there's ownership there because this person owns that car. So it's like it's kind of in the middle. So definitely those two are kind of really closely linked. Then you have we have the other ones that we need to talk about. This is going to be the event, like the actual thing that happened. So like in notifications, there was a funnel of events, right? You have like sent, or you have generated, which is like a notification that could be sent. And you have the notification that is sent. And you have the notification that is delivered to the device. Then you have the notification that's clicked on. And then you have the notification that's converted into an action downstream, whether that be like a comment, a share, a purchase, something like that. And you can think of there's all sorts of what fields, like someone made a transaction, someone took a step. someone did some sort of event, someone threw a party. There's all sorts of different events that can happen that are like what. And think of those what events usually as atomic. And because you could think of an event that's like a little bit higher level. Like, for example, you have like I threw Burning Man as a party, and that's like that is true that that's like an event, and there was probably like, but like that like is more of like a group of events because that's like a week long thing. But you could think of it as like a shorter level of like I registered with the Bureau of Land Management to be okay to get the okay to throw this party. That's more atomic, right? And you can think of like all the kind of atomic level things, and then those higher level components are like okay, those are more aggregations of because like you can think of Burning Man as like the all of those events that are happening at one time. They can kind of all aggregate up into the whole party, or like it's like a dimension almost at that point because it's like okay, all of these events are tied to this one thing, and it's like a kind of an aggregated view of one kind of set of facts. And so, but we're trying to talk about modeling individual facts. So remember that the atomicity of facts is also really important. And then this last piece is also critical for facts is the when. The when is going to be almost always modeled as a timestamp or a date, usually a timestamp. And it says like, okay, I clicked on this notification at this moment in time. And so that is critical for facts. Like without the when, like you don't know where to put it. And like some things to be careful here about is that you really do want to make sure that all of your devices are logging the same time zone. And this should be logging UTC time zone because a lot of times like when companies are moving to being more mobile first, where they do a lot of the logging on the client side, they do client side logging, then the client side logging happens most of the time in the time zone that the client is in, which is bad for when it gets pushed to the server. So you want to make sure in the client.
True story. I worked somewhere where we had to like do this change of moving things from because like in some parts of the system it had been saved as local when it should have been saved as UTC, and it was a nightmare. It was a nightmare because we had very specific. So the place that I worked, you had event time zones and customer time zones as well. So the clients sometimes wanted to see things in where they currently were, but also in a time zone where their event was hosted. And yeah, like the way that the data had been saved in some of the parts of the system made it really tricky. It was really nasty to kind of resolve, but yeah, this is a very important tip. Save things as time zone like UTC because it's a nightmare to if you don't.
Client app that they are logging things in UTC, not in whatever the client time zone is, so that when it gets pushed to the server, all of your timestamps are in the same time zone, so that you can easily know like that, like when they actually happened, and it's not all shifted because of weird time zone problems. So that's a key thing to remember when a lot of companies are moving that way because it is better to do things client-side logging because client-side logging is higher fidelity than server-side logging is because you get all the interactions that a user takes, not just the ones that cause a web request to happen. So that's a big thing to remember when you're thinking about the when of client-side logging and fact data modeling. Okay, so more things about facts. Fact data sets should have quality guarantees. Some of the key ones that I really like for fact data is no duplicates, or like that's one of the key things is like can you crunch all the data and duplicate it down so that like when an analyst is looking at stuff, it's all kind of flattened out. You also have fields that need to be there, like for example that event field, like the what field and the when field. The what and when field should always be not null. They should always be there. Like if they're not there, like what, like you can't even analyze that data if it's null. It doesn't make sense. It's bogus. So like you should definitely always, and then like really the who field should also have some sort of not null. Fact data should generally be smaller than raw logs. Raw logs a lot of times will log a lot of extra stuff that you don't actually need, that they might need for like diagnosis or for like other, like the software engineer needs it to like understand what's going on in the server, and like that's not something that you need to know to understand what's going on in the business. And so a lot of times you'll end up modeling that stuff away. Yeah, and fact data should parse out hard to understand columns. Like a lot of the times the software engineers will pass you a column that is like a string, but it's actually a JSON string that's just a blob of like nastiness, and it's like really hard to even query it. And so fact data should not have very many of those. Fact data should, for the most part, just be like strings and integers and decimal numbers and enumerations, and it shouldn't really be as much of those complex data types. There could be some complex data types, like for example, when I worked at Facebook, one of the complex data types we had was just an array of string, which was this notification was part of these experiment groups, and that was a really powerful way to like easily kind of slice and dice the notifications conversion rates based on the experiments that they were in. So it's not always the case that you shouldn't have complex data types, but like you definitely shouldn't have like these massive blobs of JSON. That's just like painful, and that's like your analysts are going to be so sad if you just like give them the raw logs and say parse the JSON yourself. Like that's like literally your job as a data engineer. Is you should be making data sets that are really fun and delightful to use, and if you're not doing that, then yeah, you're not being a good data engineer. So definitely make sure that those things are things that you are considering when you're doing fact data modeling. Now I want to talk a little bit about in one of those previous slides I talked about normalization versus denormalization. And so one of the questions with fact data modeling is when should we bring dimensions in, like instead of just like the ID, but we want to actually bring in some of the values. So I want to talk about this network logs pipeline. I'll give you a link to this as well that you guys can read more about it. So one of the pipelines I worked on at Netflix was this network logs pipeline, and this is the biggest pipeline I ever worked on in my entire career. This pipeline was, is like it did about 2 petabytes of data every single day, 2 petabytes of brand new data every single day. And one of the things that we had, and what it was the source data set was just every network request that Netflix receives, just every single one. And so that's why it's so much data. And what we wanted to do with this data set was we wanted to see how the microservices were talking to each other. Because I don't know if you know, but Netflix is actually like very famous for like pioneering the microservice architecture. And the microservice architecture is really great for making your development faster and to making your responsibilities kind of split out, and like you can really do really great things with microservices. But for security, they're actually kind of a mess, because it's like, okay, if you have, instead of having one app that you can secure, if you have 3,000 apps, think about like all the ways that things can get hacked if you have 3,000 apps. Well, there's just a lot more things.
Just to clarify with that as well, like that's true for big companies like Netflix, that it will genuinely make your teams go faster and quicker. But if you are a small startup, typically it won't give you that like speed benefit, because you'll have a small team having to do more, having to separate out their code and then factoring things like networking and latency and things like that, because they're using microservices to connect their systems. So it's not always the case that it'll make it faster, but in big companies, that's definitely true.
Things to worry about. And so what we were trying to do was we were trying to figure out like, okay, what are all of the apps and how do they talk to each other? And like, so then we can see like, okay, if this app talks to this app, we know if this app gets hacked, we know all the other apps that it talks to. And the only way that we could do that is by looking at all the network traffic. And that was like insane. But like, anyways, how it worked was we take this network traffic and we join it with this small database of IP address data that we were able to come up with, which was like just all of the IP addresses for Netflix's microservice architecture. And it worked. It actually worked. And the only reason that worked is because of the fact that that data set was small enough to do a broadcast join. And a broadcast join in Spark, for the people who don't know, is a way that you can do a join that's very efficient. But the only way it works is if one side of the join is small. And by small, I mean like less than like 5 or 6 gigabytes. If it's more than 5 or 6 gigabytes, then Spark is going to have a really hard time doing a broadcast join. But one of the things that happened was we were like, oh, this pipeline needs to be upgraded. And we needed it to go to IPv6 instead of IPv4. And we needed to bring in a lot more IP addresses. And then we realized, like, this isn't going to work anymore. This join is no longer going to work. We will not be able to figure out, like, based on IP address, what the app is. So that then we can, because after that join, what we did was, like, we figured out what the app was, and then we aggregated down to see, like, oh, this app talks to this app talks to this app, right? Because it's just IP1 to IP2. You just have, like, 2 IP addresses, and you just do that join. But, like, if you can't broadcast join it, then we tried. We literally tried to have it run without broadcast join and do a shuffle join, and, like, the cost ballooned. The cost ballooned, like, over 10 times. And so we were like, wow. Okay, so how do we solve this problem? Like, how do we solve this fact data modeling problem? Because, like, we can't just, like, give up our security questions because we want to upgrade to IPv6. And so what was the solution here? to solving this like very difficult problem, even though like we initially did solve it in like kind of a more denormalized way of solving it. So what we needed to do was we didn't need to do that join. That like what we needed was, instead of doing that, we needed all of the apps to just log their app. Every time that a network request happened, we just needed to log which app it was receiving. So then like instead of having to do this join, the app would just be in the network request data itself. So that was like really crazy that we realized that that's what we needed to do. So what we needed people to do was adopt this thing called a sidecar proxy, which what it did was every app could just adopt this sidecar proxy. So every time it received a request, it would log the app that it was coming from. So that would give us the app name, and we wouldn't need to do a join anymore. And so we would have, but now you'll see the fact data is now denormalized though, because the IP address is the identifier. And so bringing in that app information, that string information, actually does denormalize the data, because that is something that you can answer with a join. But since the data is so large and that join just becomes unmanageable, you need to denormalize it and log it ahead of time. And so every time that the data is logged, so then you don't have to do the join at all. And that made this pipeline more efficient. I mean, it was also a massive pain to do, because then we had to go and talk to 3,000 app owners and be like, yo, can you install this sidecar proxy? And we had to like get everyone on board, and then get all new apps on board as well. And that was like so many conversations, right? And that's just another great example of where a lot of the times the impact that you have as a data engineer is not writing a pipeline, and it's not optimizing a pipeline. It's actually going upstream and solving the problem at the source. In this case, the problem was we aren't logging the app on our network requests, and we're trying to walk around it by doing these joins and like trying to essentially putting a band-aid on the solution, because we were like, wow, we really need this information, but like we're going to solve it through this kind of a crazy join way. And when we realized, oh wow, we can change how the whole company manages this data and looks at security, and that was what we ended up doing. Even though like as engineers, we're like, when we think about that, we're like, which would you rather do? Own a pipeline that processes 100 terabytes an hour and does a join, or have 3,000 conversations with app owners? I mean, I think that a lot of data engineers are going to pick the 100 terabyte an hour pipeline, because it's like that's a lot of conversations, and like what if people say no, and you have to like talk with them and understand like why they don't want to adopt what you want them to do, and you have to have like debate and persuasion and all this kind of stuff like that. So, but that's a beautiful part of being a data engineer, is being able to help people understand the data practices that they need to be adopting in order to make the company better and more secure. So this is like, for me, this is like one of the more like bigger impacts of things that I worked on in my career that I noticed was like, wow, this is a great way to solve this problem. So yeah, denormalization wins in this case, right? So that just shows you that like sometimes denormalization is actually the solution to large scale problems and not the cause of large scale problems. Okay, so we talked a lot about logging. So how does logging fit into fact data? Logging should give you all the, like pretty much all the columns that you need, except for maybe some of the dimensional columns. And those, honestly, you probably shouldn't even be in the data table to begin with. You should just have the IDs, and then people can join in on those IDs to get them.
At my previous place, when we created our fact and dimension tables, we tend to only create dimensions that we knew weren't going to get that big. So that and log the things that we knew that probably would get big. So I think I think that's pretty much the essence here of like, if you know that if you know that you're going to be working with a lot of data and you can't predict what the data is going to be, then you put it in the fact table. Whereas if you know that, like for example, at my previous company, we had events, and we knew that the events, you were only going to get like a couple hundred events like in the year that would be hosting. So you knew that the actual table that you were going to be working with, like the dimension table for that, was going to be really, really small. And so it made sense to have that in a separate table. So that's just an example. Hi Swasta.
The dimensions that they need.
Swasta?
That can be a very big important thing. remember, this is all in collaboration with online system engineers. They are going to be the ones who are going to be knowing a lot more about the event generation, like when those events are actually being created in the app. So they're going to have a lot more context on that. Like as a data engineer, you probably won't have as much context on that. Another big thing is like don't log everything. Log only what you really need, because a lot of times these raw logs can be very expensive and they can cost a lot of money in the cloud. And so a lot of times companies can fall victim to this idea that like we need to log stuff like just in case. And so that's something that you want to not do. That's something that is very an anti-pattern and against kind of the efficiency ethos of data engineering.
Funny story. I have a friend who I'm quite good friends with, and they work at like another company as a like infrastructure like engineer, and they were telling me how like they had a ridiculous cloud bill because like the developers were just logging everything, and he was just like, why has it been like I'm getting all these errors in the logs, what like why are we logging all of these errors? And it was like, oh, those errors don't really matter, you know. And he was like, oh, so I can just delete all these logs then? And they were like, no, because some of the logs might be useful. And he was like, well, we'll get rid of these errors then, because these errors are making our bill go up drastically. And that was the only thing that actually got them to remove like the pointless errors. So moral of the story is um, don't log things that aren't important. Saswata, is that the correct pronunciation of it?
Where data engineering is kind of like we're going to give you all the answers to all of your questions in the most efficient way possible. So that's a big thing. The last thing I want to talk about with logging here is conformance. So when you are logging your data, there should be some sort of contract or schema or shared sort of vision for things. And this can be tricky because of the fact that, like, for example, at Airbnb, they like for a long time they had a lot of their app in Ruby, and we did all of our dev in Scala. And it's like Ruby and Scala don't you can't really just import their Ruby libraries into your Scala libraries. It doesn't work. So what you need is a middle layer between the two. So between Ruby and Scala, they shared some of the schema. So for example, like I worked in pricing and availability, and I worked on like some of the shared schemas of like, okay, what describes a price at Airbnb and what describes what's available. And these things were defined in what's called a thrift schema. So thrift is actually a specification that is language agnostic, and it's a way to describe schema and to describe data and functions as well. And data engineers mostly just use the schema part. I don't really use the function part as much, but like it's mostly like schema and data. You can describe that stuff, and it's in a way that is shared. So the Ruby code and the Scala code will both reference the same schema for price. And so I'll know if like the Ruby code is if they add another column to their price data, like I will my schema will also have that new column, and hopefully like there'll be a test there that will break my code so that the Ruby team can't push their code until they talk to me and they say like, hey, we're adding this new column that's going to change the calculations, so you need to go and update your code as well, so that like I can then go update my test and I can make sure my pipeline isn't going to produce junk data just because the online teams decide to change how they calculate price. So that can be a beautiful way to have an integration between what the online service teams are doing, like however they're calculating the things in the app, and how you are calculating your things in the pipeline. Because if you don't have this shared schema and this shared way of talking about things, those things are destined to drift, and they will slowly kind of fall apart from each other. And that's where having this kind of shared knowledge and this shared talking can be a very, very beautiful way to keep everyone on the same page and keep everyone kind of working towards the same kind of shared vision. Let's talk about some of the other things that is super important to think about when you're dealing with high volume fact data. Sometimes
Oh, that's nice, thank you. And hello, Emma.
like the solution is to not work with it, like to actually just filter it down and not work with all of the data. That can be a very powerful way to solve these problems. So, for example, one of the things I worked on at Netflix was this thing called infrastructure impact, which was a metric that like showed if an A/B test like caused a higher S3 bill or a higher AWS bill than like another experience like test and control, like the test group. Oh, like we're gonna see 2% higher AWS costs or whatever. So, but the way we looked at that was we did a sample of network requests, and we only needed to do like a 1% sample of the network requests, and that solved our problems, and we were able to build pipelines a lot faster. Different than the security problem, because in security you can't sample because you have to know all of the possible, like you have that needle in the haystack problem, right, where it's like you can't sample. So sometimes sampling doesn't work, right, in like especially in cases like security or like where you have like those very low probability events that you need to capture. Then sampling is going to essentially be a show. It's going to not work at all. But for a lot of metrics and a lot of directionality things, you really are going to, it's probably going to give you almost the exact same number or the exact same metric, but it just uses 100 times less compute and 100 times less storage. So in a lot of ways, it's more ideal. Sampling works because of this concept called the law of large numbers, which is as you have more and more examples and more rows of data, it approaches more of a Gaussian distribution. And so as you get more and more data, you get a diminishing return on what that distribution looks like. And I mean, the law of large numbers says 30, right? If you have about 30 data points, then like you start to approach that normality distribution. And so that is a very powerful technique that you can use, especially when you're working with metrics that are like mostly used to kind of gauge directionality of things, but not like when you need to know the specific row data. Because if you need to know the specific row data, that's when sampling is not going to work. Another great example of things that you can do with fact data, especially if it's high volume, is going to be bucketing, where in these cases you can bucket things on like user ID, or you can bucket things on like whatever the actor. Usually you bucket on the who IDs. And the cool thing about that is like if you need to join on that column, then you can join on that column, and then you don't have to shuffle everything. You don't have to shuffle across the entire data set. You just have to you just join within the buckets, and then it can be a lot faster. So you can do bucket joins. That is something that we are going to cover in week 5 for the infrastructure track, how to do bucket joins in Spark, and it helps minimize shuffle. And if you go to a sorted merge bucket join, which is an SMB join, then you can actually do joins without shuffle at all, because in those cases you have like
I mean, I need to like understand like these different terminologies because I've not heard of bucket join and shuffle joins.
both buckets they line up and they're sorted, so it's like a zipper. So they like come together and then it just zips down, and you don't have to. There's no shuffle that needs to happen at all. And that was a big SMB joins was a very powerful technique that I used at Facebook to really make things more efficient. It's not quite as powerful or as used nowadays because Spark kind of shuffling in Spark is like a lot nicer than shuffling in Hive was. So, but it still is a technique that I see in practice, and I even saw it at Airbnb. So it's not gone yet though. So bucketing, that's the key thing to remember. Bucketing can be a really great way if you have a very high volume fact data set. Bucketing is going to be a really powerful way that you can handle that data. Another great question is like retention. So you have high volume fact data. You can't just hold on to it forever. Dimensional data you can kind of hold on to as long as you legally are allowed to. One of the things that I noticed for fact data in big tech was the whales, which are any fact data tables that were greater than 100 terabytes. They had very short retention. Usually it was like a week, maybe 2 weeks. And those are like the whale tables, which were like, those are only like maybe 2% or 3% of all the data tables. And then it was like, if it was less than 10 terabytes, like in big tech, it was like, okay, like doesn't matter. It's the only thing that mattered was like if it got anonymized or not. And that was because they cared about the legal risk, but from the efficiency perspective, they didn't really care. Obviously, depending on the company and the budget of things, these rules might change. Maybe it's at your company, instead of 10 and 100, it's 1 and 10, or it's 100 gigs and 1 terabyte, or whatever. Usually there's an order of magnitude between like where you're like, we need to make this more efficient and we need to reduce the retention on this because the cost outweighs the benefit. And that's a big thing that, like, as a data engineer, that you should be thinking about is what is the ROI for holding on to more data. And because you'll get pushback from data scientists all the time because they're going to be like, oh, we need this data, we need longer retention on this data just in case. And that just in case rarely comes. Like every time I hear that just in case, like, I don't know, that's almost always a cop out, and that's like not like very rarely actually something that they need to worry about. So yeah, retention. Definitely thinking about that when you're dealing with high volume data. this is the last bit of this presentation, and then we'll take a break. So I talked about how deduplicating fact data is challenging because you can have general actual duplicates of data, and but one of the other things about it is like you have to think about the time frame. Like I know in notifications, right, where it's like imagine it this way: like Facebook sends you a notification, you click on it today, but then you also click on it in a year because the notification is still in your tray, and then you click on it in a year. Do we care about that duplicate? Like do we honestly genuinely care about that duplicate? Probably not. So there's going to be kind of a frame that you have to like care about duplicates of some time frame where those matter, but there's also a long tail where they don't matter. And so that's a big thing to think about is how like what is the distribution there of duplicates. And you can even look at that, like you can do some analysis on the data set itself to see like, okay, where is the big chunk and like what is the way to do this. Like I found one of the things that can happen with these things, like, so I worked on deduplicating the notification event data set at Facebook. And when I got there, that was just like one query, and it was like it took like 9 hours to run in Hive, and it was very painful because it was master data that a lot of other data sets relied on. And so we wanted to reduce the latency of that data because it was available like at like way late, and then all these other pipelines could only start after 9 hours because they were waiting on this data. So what are some options for making or reducing the latency of these deduping? So the two big ones are going to be streaming and microbatch. So microbatch might be like on an hourly basis, and streaming obviously is going to be on like a even lower basis than that. So we're going to go a little bit more into details on like how I actually deduplicated this very large volume data. Streaming allows you to capture the most duplicates in a very efficient manner because you can essentially capture the duplicates on whatever window you want. And you just like say, okay, we saw this notification ID and we're going to hold on to it. And then if we see any duplicates over the next like 15, 20, 30 minutes or whatever, then we can capture most of them that way because, a large majority of the duplicates happen in a short window after the first event. And so you can capture a large majority of the duplicates with streaming in a very small window. One of the things that was interesting about this for the requirements that I had in notifications, though, was that we needed to hold on to every notification for the whole day, and we needed to deduplicate throughout the entire day, not just in like a 30-minute or an hour-long kind of window. And one of the things that caused was there was just so much memory. It was used so much memory, and like actually streaming didn't work. I tried doing streaming stuff on this for like 6 weeks, and I could not get it to work. And I was like, wow, is this like an unsolvable problem? Like, how do we get past this problem in notifications? And but streaming, especially if the volume is less, because, keeping in mind that my problem I was working on was like 50 billion records a day. So like if your problem's less than that, you're probably going to be in a better spot where streaming is going to probably be great for your use case, especially like if your duplication window is smaller, then streaming, it can be like almost a slam dunk, and it can be one of the simplest solutions. So I'm not saying just because streaming didn't work for me.
Just wondering, like, in terms of in the scenario that you mentioned about notifications, if someone clicks on something, just say they click on it again in like an hour, why does it matter that it's duplicated? Is it just a data size thing? Is there like a reason that they need it to be not duplicated? That's what I'm not quite understanding at the moment.
That streaming wouldn't work for you. It could definitely work for you in doing these kind of deduplication of facts.
Why do I hate Apple products? What's wrong with them? I don't. I'm just not used to the ecosystem. So, I've tried to work with Macs before, and it's just very opposite to what I am used to working in. And I'm of the opinion that, like, it's the things that you work with are just tools, and I've not seen a reason why I need to use a Mac to be more productive. I don't think I need that. I predominantly working I predominantly work with Windows, but I predominantly work in WSL, which is like Ubuntu. So I'm pretty comfortable with working in that environment. So I don't see the point in getting up to speed with an Apple unless I'm given one as part of my like I nearly had to use one for a customer because they required you to use their machines, but then we didn't end up going with that customer, so then I didn't need to use one.
This was how I actually pulled this off. deduplicating the Facebook notification data. So use this thing called hourly microbatch dedupe. And so what this did was, instead of taking 9 hours, it was actually available 1 hour after midnight. So, and that was great. We were able to really solve this problem. But like, what does this pattern even look like? Like, it's probably kind of messy. So we're going to go over each piece of this real quick. So the first step in hourly microbatch dedupe is you get all the data for a specific hour, and then you aggregate down, right? So in this case, you would have your product ID, event type, and this would be for a given hour. Like for 1 hour, you collect all of the data for 1 hour first, right? And you do that for every hour, all the way from hour 0 to hour 23. You just get all of them together and you group them, and that's the first step. And what this group by does is it eliminates duplicates within an hour. So within the hour after this group by, all the duplicates are eliminated. So that's step 1. Then step 2, what you do is you do a full outer join between hours 0 and 1, or hours 2 and 3, or hours 4 and 5, etc., etc. And then what this full outer join does is, again, it makes it so that it eliminates duplicates that are across hours.
What I find interesting is just generally the terminology, because I've had to do this before, but I have not heard of the microbatching terminology. But I have had to do this. So it's just interesting. Like sometimes like you might think, okay, I've not done that before. And actually you've just not necessarily known the right terminology, or the way that you know it is different to how someone else knows it. Jay, do I have any plans making some content on YouTube? And if so, what about? Yes, I have been thinking about different things. So I've got my like MSAL auth series at the moment that I've been doing, but I was also thinking about doing more with Azure, because like recently, for example, I have been working with Azure OpenAI and APIM, like Azure API management, and I've had a lot of customers that have struggled with getting that working, and I've had to help them get it working. And so I reckon like people would probably find that really beneficial, showing, okay, how can you get this working? How does managed identity work? How does conditional access policies work? Loads of different things in Azure basically that I help our customers do. The challenge is, especially with like the OpenAI Azure services, is that I just need to verify whether or not I can get it on my MSDN like subscription, because I obviously can't film my work subscription stuff, so I'd need to use my private subscription.
So if there's a duplicate that happened in hour 0 and in hour 1, this full outer join would get rid of that duplicate, so that you could be able to have like a deduped 2 hours duplicate, or a deduped like 2 hours event stream. I mean, so then what you do is these all come together and it branches like a tree. So let me kind of show you what I mean by that. So this is kind of a diagram. So what this does is, like, you wait for your hour, and then you do that group by. That's what this dedupe hours 1 through 8 ... And then you do the merge, which is that full outer join query. And then after hours 1 and 2 merge and hours 3 and 4 merge, then these two merge together to do hours 1 and 4. And then you keep merging until finally you get down to where you have hours 1 and 16 and hours 17 and 24, and then they merge together, and then you have your final daily dedupe data set. And yeah, this like was a lot of work, but this way is a very resilient way to dedupe fact data, because like it's still batch, but like it also handles data in a very it will dedupe data in a very low latency way. So definitely, I highly recommend checking this out, because this works at pretty much an arbitrary scale. Yeah, so today's lab, what we're going to do is we're going to be looking at some of our different kind of values here. So we are working with the NBA data set again, where we have games and game details. We're going to be looking at things like teams and games and players, a couple different things like that. And we're going to be building out our fact data sets that will be using a lot of these data. Congratulations on getting to the end of the first lecture in the fact data modeling course. If you are watching on the platform, make sure to switch over to the next one in the links, so that you can get credit for every lecture and lab here. You don't want to just keep watching completely. Thank you so much for getting here, and make sure to like, comment, and subscribe. So today we're going to be working with
Okie dokie. I shall view the next lesson then.
So today we're going to be working with mostly with this table select star from game details. Let's just look at this table real quick. So this is our table, and this is what we're going to be working with. So one of the things that what we're trying to do is this table is actually terrible. Like, there's so many things that are wrong with this table, and we're going to go over a lot of like what's wrong with this table. But there's like let's just think about this for a second. So game details, like the grain. So when you're working with fact data, the grain of the table matters a lot, and the grain is going to be what is considered the lowest common denominator, like the unique identifier of this table. And for game details, in this case, we're going to be working with this, right? And so this is mostly one row here is a player and their points. So in this case, I'm pretty sure we have game ID, team ID, player ID, and then there's obviously, I think that's pretty much it. So what we want to, this is like when we identify the grain of the table, which is like for every game, every team, every player, we have, that's kind of the unique identifier here, right? And what we want to do is let's just go ahead and see if there's any duplicates in this table first. So what we want to do is we want to say, okay, this is a very common query when you're working with logs that you're going to want to run is you identify the grain of the table, then you have some sort of count, and then like, because what we're saying is this should be unique, and then this is what we want to kind of clarify. So this query, see, it takes a little bit because it's like aggregating a lot of data. So it looks like there's almost 2 of every record in here. So that's one of the things that can happen.
What do I think? Can AI replace programmers, or is it just a scam? I don't think it will replace programmers as long as they have a pragmatic approach to solving problems rather than being like, I tend to find like the programmers who are going to do well with AI are going to be the ones who can quickly adapt. So, you know, being able to use AI to help them like get better, being able to like solve new problems as they come up. Like AI at the moment is really, really bad for solving things that haven't been done before. That is just like how do you solve something when something is basically just taught on data that is there? How do you solve something that hasn't been done before? Which is I think why they're putting so much effort into trying to create like is it like truly artificial AI, like intelligence, artificial general intelligence is what they're trying to create, isn't it? And yeah, I think that's not as close as they're making it out to be.
Happen, right? And that was actually kind of intentional because I wanted to show people like sometimes like when you're logging, you end up getting double data. So that's going to be one of the very first things that we want to do is we want to create a filter here to get rid of the duplicates. So that is not too crazy, right? So let's go ahead and create a thing called deduped as. And then I can just kind of move him in here and then say, in this case, we can just put a star here. And then, so we have a row number here. And then over. And then partition by. And in this case, our partitioning is going to be game ID, team ID, player ID. And we're just going to call this as row num. And then what I want to do here is I'm going to say select star from deduped. So this will give us all the same columns
Do I use ChatGPT or Copilot more? I probably would say I use ChatGPT more, only because I use it to help me write documentation because I hate writing documentation. I find it so boring. It's the most dull thing in the world. So that's why.
Right, as the last table. But now we're going to have this nice little row num kind of feature as well. So at the very end here, you'll see row num, right? And so row num in this case is we have a bunch of ones here, but like you'll see if we say like order by row num descending, you'll see that there are duplicates in this table because we saw that with the count one kind of thing, right? Wow, I like how this query takes 1,000,000 years. Like, because it's like has to process all the data and like game details. So you see here are all these row nums too. So these are all the people that are duplicated, right? So these are all like duplicate records that we want to get rid of. So in that case, all we want to do is we want to say where row num equals 1, and that is going to get rid of our duplicates. So that's going to be our start query that we're going to work with, right? A lot of the times, like what you'll end up doing here is you're going to have like an order by here. There'll be some sort of like other thing that you order by, so that you always pick the first row. But you know what's interesting about this data set is there is nothing to order by, and that's actually one of the other problems with this data set that we're going to solve. So okay, so we have our deduped kind of game data now, and we have this rolling. This is looking great. One of the things that we want to talk about here is like there's probably a lot of things in here that don't matter. Like, for example, okay, so we have all of this data, and we want, like, one of the things about this fact data is that it's very denormalized, right? Because you see how, like, we have this, like, team ID, and then we have, like, team abbreviation, team C.
Was it hard for you to learn programming when you started, and did you want to give up? Yes, it was really hard. Especially when I started uni because there was a lot of people in my course who had already done it, like programming before, and I was coming in from like a maths background, but I hadn't really done much programming. And so like whilst they're like figuring out how to get the app running, I'm figuring out how to use the command line. And so that was quite difficult. And I hadn't used Linux before, and we were, using Linux in our like in university. So that was another thing. So there's a lot of that was quite hard, um, and then I kind of felt that way for like the first few years of my like being a software engineer. It's only been like the last few years where I've felt quite like actually, yeah, I can do this, and I can learn quite quickly, and I feel quite confident in my skills now.
City, and we have like player ID, player name, and then like all sorts of like other kind of columns in here that like really are not really necessary. And it's interesting because we actually have both columns in this table that we don't need and columns that are missing. Because one of the things that, if you remember from our fact presentation, is that we need that when, right? And there's no when column in here at all. And so the when column actually is, we get that from game. So let's go ahead and get that in our, we could just probably join that here, or we can say join games G. And so this join here will give us our, this is to be game details. Details dot game ID. So this is going to give us our, let's call this GD, just so, because this is obnoxious. Okay, so we want to keep everything from game details, but then from game, we have, you'll see there's this game date EST. So back to your question, we can actually use this to determine like, okay, are these duplicates, are they not duplicates? So in that case, we actually probably want to throw that in the order by here. We can say order by this, and then we'll just pick the first one, like based on the game date. And if those are also the same, then I think it comes back to it goes back to like it doesn't matter which record we pick. So now if we query this, let me put the game date first and format things a little bit. So if we run this, you'll see now this code is going to be looking a little bit nicer. So you see how we have the game date, we have the game ID, we have like the team ID, and then we have like player ID. But you see, like, we don't need team abbreviation and team city, because remember when we're doing fact data modeling, like if you can join something cheaply, then we don't need to put any of that data in with the fact, right? And because how many teams are there in the NBA? 30? And like even in 100 years, how many teams are going to be in the NBA? 100? Like it's never going to be like big data, right? It's ever.
Remember when I was saying earlier about the events? That's what we kind of said. Like if we know that this event is going to be what, like we're going to be doing max 100 per year. We didn't need to worry about the fact that about performance of that. So putting that into its own table made much more sense. Then why choose backend, not other IT fields? I didn't choose it. I just kind of fell into it, really. I just joined as a web developer at a company, and I just started gravitating more towards it. I just find that the problems are interesting. It's an interesting problem space. It is about solving the problem rather than making things look nice. But many of those fields are interesting. I really find security quite interesting as well, and I do a lot of security as part of my role. Hi, where should you start if you are completely new to this? I think getting to grips with the basics of SQL is probably the most important thing for you, because you really do need to understand what the commands are doing to be able to then follow along. Because if you don't understand what the commands are doing, then this is going to not mean very much to you.
Like you can put all the teams in the NBA for the next 250 years, and they will all fit in Excel easily. So the fact that we have the team abbreviation and team city in this table is an abomination, and we should not have those. But games is different, right? And that's one of the reasons why we are bringing in that game time, right? Because games is going to grow. If we, in 250 years, how many NBA games have played? You know, thousands, hundreds of thousands. There's going to be a lot of games. So like not having this game time is going to be a very, it will impact our analysis of our facts a lot more than, because if we have to join that in for all the 100,000.
I just prefer the back end. I'm not very artistic. In terms of visuals, I'm much more like analytical in terms of there's a functional problem that we have. It needs solving. How do we solve it? I don't care about how it looks. I just care about actually solving the problem. And so being a front end engineer would be like don't get me wrong, I can work on the front end and I can Like if someone else is doing the visuals, I can, help, I can write tests, I can, you know, add like I can make it look the way that they've told me that it needs to look, but I am not a visual, like I'm not an artist. So like that's why the front end isn't for me. I'm much more of a, okay, it's functional, it works, it does the logic that I need it to do. I'm happy. Actually, I really, really dislike most modern UIs at the moment because I actually think they're awful. I think they're awful, like in terms of they um they just they look they look nice, but from a functional perspective, they're really, really bad to use. Like they're really, really bad, like bad to navigate. Anyway, give me an Excel spreadsheet or give me like somebody like just give me the data in this format. I'm way, way happier.
Records, this query is going to get really slow.
Even just give me the data in a JSON format. It's way better than some of these bloody UIs that you get sometimes.
Because you saw this query right now takes 7 seconds, right? And that's only on 10 years of data. So imagine if we were doing 250 years of data. Like this is going to take a lot longer, right? It's going to grow kind of like even like it's not even going to grow linearly, right? It's gonna be even slower than that. Let's start to think about the columns that we care about here, right? So obviously we care about game date EST and game ID. Because game ID is something that like, well, let's look at that table to see if there's other things from game that we want to pull in. Because if there is, maybe that's what we want to add. If not, like, okay. So, okay, I think there is one more column from game. And then if we bring in one more column, we probably don't need to bring in game ID because all the rest of it like doesn't matter, right? So in this case, we have all of these kind of columns in here. Most of these columns are aggregate columns, right? Like for example, assists home, assists reb. Like all of these are kind of aggregate columns. We do have some things here that I think are important though, which are going to be the home team ID and the game team ID, or the home team ID and the visitor team ID, because we want to be able to see if a player plays better when he plays at home or when he plays away. So we need these two, but we probably aren't going to store them as columns. We're just going to use them to determine other things, right? So in this case, the other column that we care about here is season. You see how there's season here? So let's go ahead and put season in here, g.season, and g.home team ID, g.visitor team ID. We're going to use these mostly to compare the team ID in game details to the team IDs to these team IDs to say like, is it a home? Are they playing at home or are they playing away? So there'll be kind of like a Boolean that we'll end up using here. But we don't really need game ID after that because the main reason for that is every other column in here is an aggregate, right? That we can essentially just aggregate the game that happens on that day and we can get all of this data ourselves. So a lot of this is like derived. So that's pretty much the only columns that we really need from the game table. And so that means that we don't have to put game ID in there. So in that case, let's just put the other columns in here real quick. So we have season, home team ID, visitor team ID. Okay, and then let's go back to game details. Let's kind of look at all the columns in here. So you saw how we had, we do need team ID here, right? So in this case, we can say team ID equals home ID, right? We can say, and we can say this as, so we need team ID as well. So let's not mix these actually real quick because we have all of this already. We know these are coming from game. So let's make a new column here. We can say team ID equals home team ID as, and this is playing at home. We can say like dim is playing at home, right? That's because if they're equal, then it also has the false. This will also have the false. So we actually don't really need visitor team ID. We only need home because like there's not 3 teams in the NBA, right? So in that case, to make this query more efficient, we're going to get rid of visitor team ID
and get rid of visitor team ID here. And we don't need to have home team ID as a column, right? We need it to have it be this dim is playing at home, because this is a very valuable column that we can also have. So we can have team ID here now. Okay, so other columns here, team abbreviation, team city, we don't need. Those are, we can just join on team ID, and that'll be a quick, fast, easy join. Okay, player ID, we probably need player ID, and player name, it's an interesting one, right? Because the number of players in the NBA grows a little bit faster than the number of teams, but not that much faster, right? Where it's like, it's probably still one that we can just use player ID, or maybe like adding player name. I think adding player name is nice, because then we don't have like this is a great example of where we can add a column to make the queries nicer, so that people can just like know who the player is and they don't just get some integer. So I think adding both of those is probably fair, player ID and player name. Because player also will grow a little bit faster than team, but it will grow less fast than game. So we'll bring in both of those. So nickname, we don't need. Okay, start position, I think we do need, because that is the attribute of game, because of the fact that, like, for example, LeBron James, sometimes he plays small forward and sometimes he plays power forward. And so it depends on the game which one he's starting in. So we do need start position, because that's an attribute of the player in the game. This is like a part of the fact. And then if we go down further here, we have other columns here. We'll keep comment in for now, and we might end up doing some other things with comment later. Okay, let's go through a lot of these ones here that are probably interesting. So probably minutes, right? Minutes, field goals made, field goals attempted. We don't need field goal percentage, right? That's a waste, right? Because that's just FGM divided by FGA. So we don't need that. I think we can have the 3-pointers, right? Why is this like not going down? Okay, there we go. So we have field goal, we have the 3 points made, we have the 3 points attempted. We can get rid of that. We can do again, we have free throws made, free throws attempted. Our goal here, right, is we like anything that's easy to derive, like all these percentages, like we don't care about, right? So we can have all the rebounds, OREB, DREB, and REB. Right? Those are all the rebound columns. And then obviously we'll just keep them all here. We'll say assist, steal, block. Why is this like not letting me? Okay.
So I don't hate front end. I don't hate doing it. I wouldn't choose it as an option. I think hate's quite a strong word, but I quite like I like things that I haven't done before. I like doing things that I haven't done before. So like today, for example, it was installing CodeQL into our dev container and making sure that it ran the static code analysis for our C# like code, which seems really simple, and you know, once you figure out the commands, there's not a lot of code there. But the challenges that we had was that one, the first of all, like it's not just enough to install CodeQL. You have to install the binary, the bundle. The second thing was that the C# queries doesn't actually run the security extended pack. So you had to figure out a way to actually, how do you run the extended pack? And then another thing that was happening was because we was running in the dev container and because we were running it through a makefile, it wasn't getting the correct permissions. So you had to figure out what the permissions were. And that's the sort of stuff that I really like doing, figuring out something that I haven't done before to then showcase to our customers how you can do it going forward. So stuff like that's really fun.
Like Then we have turnover here. So this column is dumb. So I would probably rename this TO column because of the fact that you see it's like blue. You see how like we're getting this like squiggly here? Because TO is actually a keyword, right, in SQL. So what we can do is TO, and then I would actually just rename this as turnovers because that's what it actually is. So that like we don't use keywords. Using keywords in your columns is bad. Like imagine calling your columns select. That's like a terrible name for a column, right? So we have personal fouls, points, and we'll keep plus minus in there as well. So these are all the columns that I think we should keep because they're all like fundamental.
As someone from the UK, these columns mean nothing to me because I have no idea what the game, like what the points are.
Nature of the fact. So this is really close now, but let's go ahead and just run this query. And because I think there's one more thing that I want to show with what this is doing. Okay, it's running. It takes like 8 seconds, right? Wow. That's a slow one. Like, I did not expect this to take 15 seconds. Like, this is like not that much data, right?
I'm just saying, Zach, mine took 4, so who's winning here?
We might want to put like a where clause in here somewhere to like have this be filtered down. So here we go. This is our new data set that we have, right? So now we have our game date, we have our season, and we have the team. And then we have dim is playing at home, right? And you'll see it does have the check, right? So it is like there is a home team and away team. Then you have our player ID, start position. So you'll notice that some people have a null start position, which probably means they didn't play. Okay, so one of the things that you'll see here is there is this comment is an interesting one where there is, you see there's like DNP, like there's a couple different things for this comment that I think are interesting. And like, because this comment is a really hard dimension to work with because it's like kind of like very high cardinality. But you see the first little bit there is, wow, dude, okay, there we go. You'll see there's like DNP, so there's 3. There's NWT, DNP, and DND. Those are the 3 that are there. And what they stand for is did not play, which means they are sitting on the bench. They just didn't play. And then there's a DND, which is did not.
Just wanted to say thank you, Sam. Thanks for stopping by. Appreciate the like button. I did the same for you earlier. I haven't done many Udemy courses, to be fair. I think there's a lot of good stuff there on Zach. Doesn't Zach cover a lot of the basics on his channel? I'm not sure, but I think even like Microsoft have like SQL Foundation courses that are free. I'd have to check, but there's a lot of resources out there for sure. Yes, I am doing this. I'm trying to do it for every lecture for sure. So I'm just I don't know like if people feel this too, but having like a body double is really helpful for me. So like it keeps me motivated. It keeps me engaged. I know that on the night I'm just going to sit down and learn, and then I can talk to people as well to kind of break it up a little bit and to make it a bit more fun.
Dress, which means they showed up to the arena and they were there, but they weren't ever going to play because they didn't ever even like wear their uniform, right? They didn't wear their jersey. And then NWT means that like they weren't even in the arena. They were like not even there. So you see here's DND, right? All these different did not travel, right? So I honestly think that these columns here, like we want to essentially look at these together to see like maybe these are other facts that we can learn more about these players with. So I would think that like this is this column is a great example of like a raw data column that we would want to parse. So in this case, what we can say is, I think there's a, so there's a way to do this, like, so let me show you how this works. This is like a very strange Postgres thing. I'm gonna put one more thing in here. I'm just gonna put I'm just gonna filter this down for now so that like this query doesn't take so freaking long. A 10. Okay, we'll do 10:04, so that we can. This query should really be fast. There we go. There, now it's like instant. So we're filtering down to just 1 day of data so that like we don't process everything at once. So one of the things you'll see here is we have this thing called position. So you see this is like equals, like, so what this is doing is like, this is doing like a string position. So we're saying like, is DNP in the comment, right? And you'll see it is in this comment and it's at position 1, right? So in this case, we want to say this is greater than 0. And then what we want to do here is we can say coalesce this with 0, because we want this to be a Boolean, right? But like when it's null, if there's no comment, we want this to be false because we know that it's not DNP. Because so now if we run this, let's call this as dim did not play. So if we run this, there we go. So now you see how we have, it has the check marks for those days that were dim did not play, right? And so this column is going to be way better to work with than that comment column, right? And like, this is a very common thing to happen when you're working with fact data. So one of the things we want to do is we want to add in a couple more here. That's like dim did not play, dim did not dress. And then we want one more here, which is dim, this is not with team. And then this is NWT. And so this will give us all 3 of those columns.
Dry butter chicken. Yeah, that's a nice one actually. I've not ever made it myself, but I do like it from a restaurant, so that is probably a good one to try. Do you have any good recipes that you'd recommend?
And that should, you'll see, we'll have all 3 of them now. And then there'll be which ones are kind of checked off, right? Here's did not dress, all sorts of things like that, right? And like one of the things about this though is that they kind of cascade on each other, right? Because of the fact that you have like, if they did not dress, they did not play. And like, so these all of these things kind of like cascade on each other because like, but like, so that's one thing to think about, right? So, but that is something that we can do later on. That's like, I think that like having these be like this and like just logging like the raw, like, is this data here or not? And not really baking in the business rules at this point is probably the better play. And then letting analysts kind of work with these columns themselves later on is probably the better play, so that they can see exactly what was in the data. So that's pretty much what is in that comment column. So because we now know it's in that comment column, we can probably just not even have it, right? It's an interesting trade-off here of like, if you feel like you parsed everything or if you haven't. But I'm feeling pretty good about it, so I think we can get rid of it. So this is now looking pretty close to what we want. Let's go through all the rest of the columns here and just see if there's something else that might be missing. So the game stuff looking great, team ID great, playing at home. Then you have player ID, player name. Then you have their start position, and then okay. So I hate this column. I hate this column so much. Like this min column. Like what are you gonna do with this column? Like like this is this is not a column that I would want to use, right? So I think that we probably want to change minutes here to be maybe fractional instead of this, because this should be this is a string right now, right? So that's a terrible column, right? So let's go look at, let's change this. You can do a thing called split part. Okay, so I think if we do this, is it that? Okay, we'll say like as minutes, right? And maybe
okay, so we're doing split part.
is it split part 2 as seconds? I think that's what we want. But then we can maybe turn that into a decimal. There we go. That's exactly right. So now that is going to give us what we want. So that is essentially what we want here. I think what we can do here is kind of like, I just like to use fractions. Like, I don't think putting minutes and seconds like this is a great example of like, okay, when like, what is the query pattern that our analysts are going to be looking for? So in this case, what I would say is we can say we can cast this as real, and then what we can do is we can do plus this. We can say cast as real, and then this is going to be minutes. So I'll paste you guys this query in just a second, and I'll show you like what this is going to do. So So that is essentially what we want here. I think what we can do here is kind of like, I just like to use fractions. Like, I don't think putting minutes and seconds like this is a great example of like, okay, when like, what is the query pattern that our analysts are going to be looking for? So in this case, what I would say is we can say we can cast this as real, and then what we can do is we can do plus this. We can say cast as real, and then this is going to be minutes. So
I don't understand how that would make it work, because wouldn't this be showing in seconds?
I'll paste you guys this query in just a second, and I'll show you like what this is going to do. So now, well, that looks like,
Doesn't this need to be divided by
what?
60?
Oh, you're right. You're right. I missed the division. I was like, what? You're totally right. Thanks for the catch there of dividing by 60. There we go.
That was funny though, because he wasn't saying that to me, but it sounded like he was saying that to me.
There we go. Now this is looking better, right? So now we have like, this is now a usable column, right? Where when people are looking in doing analytics, now they can do things like field goals per minute, and they can do free throws per minute or rebounds per minute. And you can easily turn this into a rate. That is going to be a very powerful thing that you can do with this column. That's a big thing to remember when you're doing fact data modeling is like, are the columns that you're even giving useful, right? And so now I think we're pretty close here to having what we are looking for our table. So let's go ahead and make our DDL, because I think that's probably, because I think, hold up. Okay, that is a date. Okay, good. So let's go ahead and create this DDL. So we're going to say create table. We're going to call this fact game details. So this is going to be our table here. Okay, and so do we care? So like this is another great example of like where we want to think about each column name, right? And so this first column, do we care that it's Eastern time? Probably not. It's a date. So I think the first column here is going to be game date, which is going to be a date. And then, so one of the things with fact data is a lot of the times you want to label the columns either as measures or as dimensions. So in this case, season here, like our game date is probably not game date. It should be dim game date, and then you have dim season, and this is an integer, and then you have dim team ID. This is an integer, right? I think, or is this a long? Oh, I think we want to be careful there. I think it should be good. I think because this is only like 1 billion, so I think we can say integer, but it's like, yeah, that one's pushing it, right? And then we have that dim is playing at home, and this is going to be a Boolean. And then let's go over again. So I like to put the more identification columns first. So we have like game dim team ID. Then we should have dim player ID, which is going to be an integer. And then dim player name, which is going to be a text. So then after that is where the columns can be kind of like flipped. I think the start position is probably going to be the next good one though, like dim start position. It's a text, right? Then we have all the same columns that we had, like dim did not play, Boolean, dim did not dress, Boolean, dim not with team, Boolean. Okay, so great. Then we have a couple other ones here. Then we have minutes.
Wow.
So in this case,
Hi,
minutes is
Black Dub.
actually a measure. So in this case, a lot of times people like to put M in front of it, like M minutes, because it's the number of minutes that was measured. And this is going to be a real, or you can say real or a decimal. They both work. I like real here, because decimal makes you like provide like the actual like precision. So field goal FGM should be M FGM, because that's field goals made. It's going to be an integer, then M FGA, integer. All right, let's do a couple more here. MFG, 3M, integer, MFG, FG, 3A, integer, right? Because you want to put all of these over, right, into what they, like, so that people are aware, right? Because if you have these naming conventions of like, okay, if you put dim, that means it's like, these are columns that you should filter on and group by on. And M these are columns that you should aggregate and you should like do all sorts of math and stuff on, right? So we can say MFTM, we can say MFTA, MOREB. mdreb and mreb, right? And then I think we're almost there. Then we have massist, msteal, mblock, mturnovers, and I think, oh, we have 3 more. So then there's
God, why is it? This is never ending.
personal fouls, m points, then m plus minus. Okay, so great. Now we have to do one more thing here, which is what is the primary key of this table, so that we can make sure that we have more guarantees on this, right? So we can say primary key. So I think in this case we're going to have dim game date, and then
Player ID.
dim game date, probably dim player ID. And I mean, technically you could put team ID in there as well, but is that really necessary as the primary key? I think it is. Like, I'd put it in there too, because you might be filtering on that, and that the primary key helps create indexes. And that would be my one thing I would say why we'd put team ID in there. So let's put all 3 in there. We're gonna say dim team ID, dim player ID. The reason why you don't need to put team ID is because it's like, can a player be on 2 teams on the same day? And I think the answer to that is no. Like, unless someone can like switch teams halfway through a game or something like that, and I don't think that that's actually possible. And so now what we need to do is essentially do all of these over into the right kind of columns here, right? So, okay, so we created the DDL, and then what we want to do is essentially move our query with a bunch of as, right? So we're getting this as dim game date, this is as dim season, as dim team ID. And remember, we want to fix the ordering here. So dim T, then we want to put player ID, player name. As dim player ID. Okay, so then we had start position. This is as dim start position. Okay, so now we're close. And what I have start position, and then we have
This is fun. I am not vegetarian.
the playing at home. Then we have all of these. And then I think everything else is in order, and I don't have to freaking worry about it. Yeah. Okay, so then this is as m minutes. Then can you do column selection mode here? Oh, yeah. Oh, I should have done this like before. See, oh, that's so much better. So satisfying to do that. Oh, wait, no, we got to do it as like, gotta put it on the other side here, right? Oh, no, because these are as, right? Oh, man, it's, you actually, you can't really, it's probably a way you can do it that way, but like, whatever. Let's do it, mfga, mfg3m. This is not going to take that long. mfg3a, as mftm, as mfta, as moreb, as mdreb, as mreb, as massist. So one of the big things I'm trying to illustrate here is like, yeah, like you should be changing the name of things, like if you are doing fact data modeling, because like a lot of times the names of columns that you're given are terrible, and this is a great way to fix them. Okay, I think we got it here. So now what we can do is we can we can do an insert into here. So let's go ahead and do that. So we can say up here, I'm going to get rid of this thing here. Oh, let me turn off column selection mode. I'm going to get rid of this real quick, and then I want to say insert into fact game details.
In game day. Dim play ID. Do you know? Why is that not working? There. That's it there. Silly me.
So now this query is going to run. This query is going to take like, I don't know, like 20, 30 seconds. Oh, there we go. It's done. There we go. We don't have to debate about why it's slow, even though it took 2.5 minutes. It definitely should not have taken 2.5 minutes, but it because it's only like a couple thousand rows of data. But okay. So now we have all of our data here, and we
Okay. I missed the comment on, so I need to put, did we say?
wait, as dim player ID. Okay, so then we had start position. This is as dim start position. Okay, so now we're close. Then what I have start position, and then we had the playing at home. Then we have all of these, and then I think everything else is in order, and I don't have to freaking worry.
Okay, so we got rid of comments.
Okay, so then this is as m minutes. Then can you do column selection mode here? Oh yeah. Oh, I should have done this like before. See, oh, that's so much better. So satisfying.
What I'm going to do is I'm just going to take this player, probably that there, and just compare game day, dim season, dim team ID, player name, start position, is playing at home, did not play, did not dress, did not with team, and minutes, FGM, FGA, 3M, 3A, FTM, FTA, Reb, Dreb, Reb, Ast. Okay, that's missing. That one's the one that's missing. Okay, it's completing.
Trying to do that. Oh wait, no, we got to do it as like gotta put it on the other side here, right? Oh, no, because these are as, right? Oh man, it's you actually you can't really. It's probably a way you can do it that way, but so now this query is gonna run. This query is gonna take like I don't know, like 20, 30 seconds. Oh, there we go. It's done. There we go. We don't have to debate about why it's slow, even though it took 2.5 minutes. It definitely should not have taken 2.5 minutes, but it because it's only like a couple thousand rows of data. But okay, so now we have all of our data here, and we can see all of these different columns. And one of the things that is really nice about this is now we have all like people like we follow all the right naming conventions. We don't have any duplicates of like excessive things that we need, right? Because one of the things that like is like sad is that we lost the teams, right? But if we just join teams T, right, on t.teamid equals gd.teamid, right, and then we say t.star gd.star, we do that, right? This is just going to be gd.teamid. What? Oh, this is dim teamid. That's why. So obviously you want to model everything that way, but then okay, so now you see we can just bring in those columns, right? And we can already like we can have columns. We can just bring them in, and it's really cheap because that team column is very just not expensive. So that can be a very powerful way to use your team or to bring teams into this, even though like we removed them from the data set. So like one of the things I wanted to show here though is like okay, so we have like all this data here, but like let's just I think one cool column to do here, like let's find the player who didn't like, so let's do case when dim not with team. So like let's find the player then one, and the player in the NBA who like bailed out on the most games as most bailed. We'll call this bailed num. All right, so we say group by one, order by two, descending. Right, now this query is like way faster, right? Boom. And now you can see exactly who this guy missed 21, right?
It depends how long you want to do it for. You should definitely be able to catch up by when it's going to be taken off the off the channel, which is at the end of January. It just depends how much time you have to do it. So like for me, I'm dedicating I guess about 10 hours per week to do this and the homework. So the labs that they take about 6 to 7 hours because you're having to stop and pause and watch and stuff like that. So I'm doing 2 hours for every 1 to 1.5 hour really, and then and then you have to do the homework, which is another couple of hours on top of that.
See, like, this is the number of people who, like, you can see exactly the number of times, right, that they did that. But, like, maybe it's different, though, right? Because you also have, like, count, you can say count one as num games. Because one of the other things to think about is, like, okay, but what about that, like, kind of bail percentage? That's probably the last thing that we want to think about here. And then I think that will be the end of this presentation. But if we say like this, right? So if we cast this as a real, this is, we're going to call this as bail percent. So we want to order by 3 descending instead. So now this query is really better, right? So you see here's our bail percentage, like, which didn't sort.
Oh, yeah.
What? That definitely didn't sort, right?
Okay. That's a cast.
Like, these numbers are, oh, it's because this is 4, that's why. Okay, there we go. So this is probably the better way to look at it. Okay, so this guy, BJ Taylor, he has like, he's 100%. He's shooting 100%. So there's some people who are like half the time, 20% of the time. So, but you see the people who had like the high numbers, like they had like 20 bails, but they actually just had a lot more games. So it was like, for them, it was more of a volume thing. So, but you can see how, like, this query that we just ran here is very powerful, and we were able to answer really cool questions from this data set that, like, would have been a massive pain to answer with the old data model. So this is the whole idea behind fact data modeling, is can you build data sets where you can answer questions like this really quickly, right? And, like, obviously you can do amazing things with this. Like, you can say, like, the number of points, right? You can say as total points, right? You can see all sorts of, like, whatever kind of aggregations and stuff you want, right? You could also put in things like dim is playing at home, and then you group by 2, right? And then if we group by 2 and order by 6, then we can see, like, okay, who is the person who has the highest bail percentage when they play at home or whatever, right? So, and you can see it's this Elliot Williams guy because he's 100%, right? And so that's the whole idea here, right? Is can you make queries that are, or tables that are easy to query, fun to query, and that is, if you can do that, that is going to be a very powerful thing for you as a data engineer.
Congrats on getting to the end of the day 1 lab. I'm really impressed with your hands-on abilities here. If you're taking this class for credit on the platform, make sure to switch out to the next link so that you can get the credit that you deserve. And good job on being hands-on.
So that's, I think, where I'm at to today. Just think I am. That's all I wanted to get through, to be fair. But yeah, I'm happy with that. I think I followed that one quite well, but it's only because I've done a lot with facts in my previous role, because we were moving over to it, where I didn't get to the aggregation as much in my previous role. So this was much easier to follow than last week's for some reason. But it was really, really interesting, and I thought it was really, really good. And it's really, really nice to have the things that I did before be validated that, yes, that's the right thing to do because of X, Y, and Z. And so that was good. I do stream every day. I'm trying to, I've been streaming every day, but it's a new thing and I don't get to do it all the time. So my partner's away at the moment, he's in Sweden. And so I have a bit more free times on the night, whereas in the rest of the weeks, I'll probably be streaming like 2 to 3 times a week just because of availability. But I am done for the day. I'm going to save my query so it doesn't get lost because I'm pretty happy with that. And yeah, I am done. I have done my current day 1 lab. I'm just going to check that it has been successfully stored as credit. And it has been. Cool. So, yeah, tomorrow I'll probably try and get through these 2. Fun learning with you too. And make sure when you are learning with me that you put the Zach's video on in the background so that you get the credit as well, because we're doing it together, but you know, he still deserves the watch hours, and he, you know, and you still deserve to get the credit as well for doing the watching. So just make sure you have it on the background as well. Cool. Thank you. I am going to go now. That is me done for today. Well, it's just gone past midnight now. Thank you for those who have watched throughout the full stream. It's been great speaking with you. Just want to give a good shout out to Lakshay. Let me just say your name. Sash. Just want to make sure I get it right. Saswata. Thank you for all your helpful tips on what I should try to make food-wise. That's been great. And yeah, thank you to everyone else who has been watching. I'll see you next time, probably tomorrow, same time again, maybe a little bit earlier if I can. I'll see you then. Goodbye.